we have a right angle triangle, angle x, adjacent side, opposite side, and the hypotenuse. And we know through Pythagoras' theorem that we can state this. Sine x is equal to the opposite over the hypotenuse. So sine squared x, so squaring both sides, will give you this. And likewise, cos x is equal to the adjacent over the hypotenuse. So cos squared x will give you this. So if we add these two together, so we've got sine squared x plus cos squared x, which is equal to O squared over H squared. That's the sine squared x ratio here, plus A squared over H squared, which is the cos squared x ratio here. And we have two fractions, they have the same denominator, which means we can write everything like this, using that common denominator. And looking up here, O squared plus A squared is equal to H squared. So the numerator here is just H squared, which means if this is H squared and we're dividing by H squared, well, that's just equal to 1. So using some basic properties of a triangle, using properties of a right angle triangle, Pythagoras' theorem, we've shown that sine squared x plus cos squared x is equal to 1. This is an identity, so you can write it like this, with the 3 lines there. The difference between an equation and an identity is that an equation is only true, it only balances for certain values, but an identity is true for all values. So you can put any value of x you like here, and you will always get 1. So both sides are identical. To use this identity, the angle here and here must be the same. So you could have sine squared 3x plus cos squared 3x, and that will give you 1. You could have sine squared x minus 20 plus cos squared x minus 20, and that gives you 1, because the angles here are the same and the angles here are the same. So you're not just limited to having angle x. This can be rearranged into sine squared x is equal to 1 minus cos squared x. That's a useful form. We could also have cos squared x is equal to 1 minus sine squared x. Starting with this identity again, if I divide every term by sine squared x, so if I divide by sine squared x throughout, then we get sine squared over sine squared, which is 1, plus cos over sine. Now sine over cos is tan, so cos over sine is cot, but this is squared. Cot squared x is equal to 1 over sine is cosec, but this is squared. Cosec squared x. So this is a very useful identity to memorize. So it can be written like this, because it is an identity. Starting with this again, if we divide this time by cos squared x throughout, so we have this, then sine over cos is tan, but this is squared. Cos squared over cos squared is 1. 1 over cos is sec, but this is squared. So this is also a very useful identity that should be memorized. So there you have it, the Pythagorean identities, which you should memorize.